Hello and welcome to week 6 of game development in the Forge. We're leaving our unit on world building and entering the nitty-gritty topic of mechanics. This week we'll be taking a really close look at how space and time are defined and manipulated within a game. Let's begin with space. Every game takes place in some kind of space. Most sports take place on a field or a court. Most tabletop games take place on a tabletop with a board or some special arrangement of cards and tiles and dice. Video games have a wide array of spaces they take place in, including 2D and 3D worlds. But let's peel back this layer of the obvious and look at spaces more abstractly so we can recognize how they serve as a mechanic. As a game mechanic, space is essentially a mathematical construct. An easier way to say that is that space is simply a relationship between boundaries and what is possible within those boundaries. Now, the two terms we need to get comfortable with here are discrete and continuous. In simple terms, a discrete space is one in which we only care about the boundaries and not necessarily what's going on within those boundaries. For example, in a game of tic-tac-toe, an X placed anywhere inside that center square is considered the center square, right? In other words, it's the same move no matter where it's placed within that center square. However, placing an X outside of the bounds of that center square changes the meaning of the X altogether. It's a completely different move. Now let's talk about continuous space. Now, continuous space still has boundaries, yes, but it's also very concerned about what goes on within those boundaries. As an example, let's look at the sport of soccer. A soccer field has very specific dimensions, and the game is confined within those dimensions, within those boundaries. Players and the ball are able to move about freely within those boundaries. However, there are also rules that dictate what a player can and can't do within those boundaries as well. A really important step in developing games is coming up with an abstract model of the space that your game takes place in, so that you can better understand the relationships between the components of your game. Let's go back to tic-tac-toe. We can abstractly represent the game of tic-tac-toe as a discrete, two-dimensional grid made up of zero-dimension cells. What does that mean, zero dimensions? All that's meant by zero dimensions here is, again, because this space is discrete, we really don't care what goes on within those boundaries. In other words, there's no special dimension or significance to what is in between these boundaries, zero dimensions. Now, it can also help to abstract different aspects of a game differently. Let's return to our soccer game. The basic construct of a soccer game could be thought of as a two-dimensional continuous space, right? You have a rectangle filled with continuous space that play happens in. While this may be all that's necessary to understand the basic play of the game, looking at it some other ways could provide some real insight. Let's apply the two-dimensional grid of cells to the soccer field, with 9 main area cells and 2 added cells on either end representing the goal. This is a useful way of analyzing what kind of play occurs on different parts of the field. For example, if one team has control of the ball on one side of the grid, that's going to change the strategy of the defending team a lot. Now, there's no hard, fast way of abstracting space, and there's really no correct way to do it. However, it is very important for game designers to go through this process in order to better understand how the game is played. Now let's talk a little bit more about the arrangement of space. In his book, The Art of Game Design, Jesse Schell draws a comparison between game design and architecture. When we think of classic architecture, we tend to think of just how a building looks from the outside. In fact, really good and influential architecture has much more to do with how a person experiences a building from the inside rather than the outside. Schell states that the primary purpose of architecture is to control a person's experience. It should sound familiar because it's exactly what game designers do. Let's look at 5 common ways that game spaces can be arranged. Numero uno is linear, where a player can only move forward or sometimes backwards on a line. You can see how linear a game like Candyland is, where there's a clear start and a finish, and you only move forward and sometimes you get sent back on that single line. Even Monopoly, even though it goes around in a circle, right, it's really just a line of squares looped back on itself. In Super Mario Brothers, you play through a level, beginning to end. The second way spaces are arranged are on a grid. Now, grids can help keep things in proportion, and they're pretty easy to understand for the player. And they can be made up of just about any shape. If you played Settlers of Catan, our unit on chess. Chess is a grid-based game. Talking about video games, Minecraft. It's a 3-dimensional grid of different kinds of blocks, right? The third way is a web. A web are points on a map that are connected by specific paths. Now, multiple routes to a specific point are a plus here. If there's only one way to get somewhere, then you're kind of bordering on linear. These paths can be meaningful, or things can happen while you're on these paths between 2 points, or they could just be instantaneous and there to provide means of orientation. Some examples of this could be Club Penguin, Puzzle Quests, or in the tabletop genre, Pandemic. Now, the fourth way we can arrange spaces are just points in space. This is a lot like web, but without the specific paths in between the points. This allows a lot more freedom for the player, in which they can discover their own paths or routes to certain parts of the map. Very popular with RPGs, Animal Crossing, and Final Fantasy to name a few. Now, the last way is divided space. Now, this most closely mimics real-world maps, where areas are defined by large and irregular borders. Now, this is great for games that are really going for a sense of realism because they're familiar to us already. Games like Risk, Axis and Allies, Civilization, all these make use of divided spaces. Now, no matter what way you arrange the space in your game, it's very important to consider landmarks. Landmarks are what a player remembers most, and it's how they orient themselves within a game space. The defined continents in Risk are both memorable and familiar. Fire Mountain or the spires of Hyrule Castle are clear markers in Ocarina of Time. Whatever your space is, make sure you have things that stand out clearly so that the player understands where their play is taking place. The last thing we'll go over today is time. Now, while time ceaselessly marches on in our own reality, it can be bent, stretched, stopped, and even reversed within the space of a game. And like space, time can either be discrete or continuous. Perhaps the most ubiquitous example of a discrete time is that of the turn. A turn exists at the beginning and the end of itself, with an eternity or a millisecond in between. Just like space, in discrete time, we're not concerned with what's within the boundaries, only with the boundaries themselves, the beginning and the end of a turn. For example, people used to play chess through correspondence or snail mail letters. They would send a single move in a letter that could take months to reach its destination. Now, while months passed in real time, as far as the game was concerned, time stood still on that single turn. Not until that move was received and a piece actually moved on the board did time actually advance for the game. Now, continuous time is what we experience in our own reality. And most sports operate on some kind of continuous time scale, like the length of a quarter in a football game. A lot of modern action video games are presented this way as well because it adds to the sense of realism. Also similar to spaces, time can be nested. A good example of this is like a shot clock at a basketball game. Now, time is measured for the quarters in a game, but a much smaller amount of time is actually given to each team to actually make a play. This pushes the players to take more risks and makes for more interesting gameplay. Space can be nested much in the same way. At the highest level, your space could be broken up into points in space or a web, right? But at each one of those segments in the web, you could have a linear form of gameplay. But back to it, one of the coolest things about designing games is it gives you the chance to control and manipulate time. Some questions to consider about time when you're making your game are: what determines the length of an activity in the game? Are the players bored because my game is taking too long or a turn takes too long? Even asking if you want to make time a factor or mechanic at all. Is your game better off without any kind of time constraints? Time and space play a huge role in the fundamental architecture of your game. It will serve you well to really spend time tweaking around these ideas and coming up with abstractions till you have something solid and understandable. I'm really looking forward to see what you come up with, and we'll see you next time in the Forge.